Okay, for what we have in worksheet number 5, okay, we have in the first problem we are looking at the integral of x cubed times the natural log of x dx. And in this particular problem, okay, we have with the integration by parts, okay, we're looking at setting u equal to the natural log of x, while dv is set equal to x cubed dx. Okay, so for what we have in this particular setting, again, we have u is equal to the natural log of x, and so taking the differential of both sides, u goes to du, and for the natural log of x, okay, this will go to 1 over x dx. And as for dv equal to x cubed dx, okay, again, we're taking the antiderivative of dv, okay, and so we have with the resulting statements, we're going to have that v is equal to x to the 4th divided by 4. Okay, now, in terms of the integration by parts, okay, we are looking at u times v. Okay, so we have u is at the natural log of x, v is at x to the 4th over 4, multiplying together. We have x to the 4th over 4 times the natural log of x, and then we have minus the integral of v times du. Okay, so if you look at cross multiplying 1 over x times x to the 4th over 4, okay, that is going to be at 1/4 of x cubed. So we can say in this we have minus 1/4 of the integral of x cubed dx. And as we look at taking the antiderivative of that particular integral, again, we have x to the 4th over 4 times the natural log of x minus 1/4 of what is going to be x to the 4th over 4. Again, having taken the antiderivative of x cubed dx once again, and so we have in the solution, okay, we end up with our terms in the answer, which in this case would be x to the 4th over 4, natural log of x minus 1/16 of x to the 4th, followed by the constants. Now, in the case of what we have for the second problem, we have x times the cosine of 3x dx. Okay, so we have another integration by parts challenge. Okay, and so for this particular problem, alright, we can now set u equal to x, dv equal to the cosine of 3x dx. Again, with u, we take the differential, and that which we set to dv, we're going to take the antiderivative, and having set dv equal to the cosine of 3x dx, okay, now the antiderivative of cosine is going to be sine, and with the multiple angle, we're going to divide by the coefficient alongside x for the angle. So for the antiderivative, we have that v is equal to 1/3 of the sine of 3x. And with the integration by parts, okay, we now have for u times v, okay, we have u at x, v at 1/3 of the sine of 3x. So in multiplying, okay, we have 1/3 of x times the sine of 3x, and we have minus the integral of v times du. So we have v at 1/3 of sine of 3x, du is going to be at dx, and we can bring the coefficient 1/3 to the outside. So we have minus 1/3 times the integral of the sine of 3x dx. And so following through with the antiderivative, of the integral of the sine of 3x. Okay, antiderivative of sine is going to go to negative cosine, and again with the multiple angle we're going to divide by 3, so we have negative 1/3 of the cosine of 3x and so for this particular integral we're going to have in the solution, okay, two antiderivatives followed by the constants, and so we will end up with 1/3 of x times the sine of 3x. Okay, negative 1/3 times negative 1/3 is going to be a positive 1/9. And this will be of the cosine of 3x followed by the constant. Okay, now for what we have in the case of problem number 3, okay, this is going to be a little bit of a challenge, and now we're going to once again deal with the integration by parts. And so for what we have in the case of problem number 3, okay, we have t times the natural logarithm of t plus 5 dt. And so for what we're going to have, once again we have t times the natural logarithm of t plus 5 dt. Okay, and now we're going to set u equal to the natural logarithm of t plus 5 and dv equal to t times dt. So we have in the setup, again taking the derivative of the natural logarithm of t plus 5, okay, we can just take the reciprocal, and the nice thing about this one is that the derivative of t plus 5, okay, is going to go to 1, and so we have for du, okay, that is going to be equal to the reciprocal of t plus 5 dt. And as for the antiderivative of t dt, okay, we're going to have for v, this will be equal to t squared over 2. Now, for what we have in this problem, again with the integration by parts, okay, we have for u times v, okay, this will be t squared over 2 times the natural logarithm of t plus 5, and then we're going to have minus the integral of v times du. Okay, and we have posed a little bit of a challenge in this setting. Okay, we're going to have minus 1/2, and this will be of the integral of t squared all over t plus 5 dt. And what is going to make this problem challenging is that we're going to be looking at long division, since we have in the numerator a higher degree in the variable t than what we have possessed in the denominator. Okay, so we have t squared over 2 natural logarithm of t plus 5. Okay, if we step to the side for just a moment, okay, taking long division, namely taking t plus 5 into t squared, okay, we're going to have at this particular juncture okay, so we have our t plus 5 into t squared. Now we'll just call this plus 0t plus 0, since we do not have a first degree variable or a constant after the t squared. So we have the long division. We have t into t squared is going to be at t, and t over t plus 5 is going to be t squared plus 5t, and carrying out the distribution of subtraction, t squares will go out, and then we have minus 5t. We can bring down the 0, and then we have t into negative 5t is going to be a negative 5. Negative 5 times t is negative 5t. Negative 5 times 5, it's going to be a negative 25. And with the subtraction, okay, negative 5t plus 5t will go out. 0 minus negative 25 converts to positive 25. And so we have, with the quotient and the remainder, we have t minus 5 plus 25 all over t plus 5. And as we carry this over to our integral statements, okay, we're going to have in the setup, again, we have minus 1/2 of the integral of t minus 5 plus 25 all over t plus 5 dt. And so for what we are going to arrive at in the next intermediate stage, still have the first antiderivative recorded, and then we have minus 1/2, and then for the set of antiderivatives that will follow, okay, which we will arrive to after we distribute negative 1/2 over the integral t minus 5 plus 25 over t plus 5. Okay, so we have t squared over 2 minus 5t plus 25 times natural logarithm of t plus 5 followed by the constants. And so we have, for the final result, we have t squared over 2 times natural logarithm of t plus 5. Okay, then we have minus t squared over 4. And then we have negative over negative is a positive, so we have plus 5/2 t. Okay, then we have minus 25/2 times natural logarithm of t plus 5 followed by the constants.